Hello everyone and welcome to another video for Elephants VFX Patreon feed. Today we're going to be talking about USD in depth, kind of the same thing we did on the last video. If you remember, I have the slides here from the other day, and last time we spent like 3 hours or so talking about USD data and structure. So that was mostly talking about USD layers and everything that goes inside of those USD layers. That tends to be things like attributes, creating print bars, and everything that is associated with defining a print bar or creating USD data. Today, it is the second part of this boring lesson, which is USD composition. And as you can imagine, USD composition is basically taking all the data that was stored in those USD layers that we saw the other day and using it for creating a 3D scene and something that we can actually render. So this video is also divided kind of like into different sections, but we're going to cover both of them today. So by the end of this video, you should be familiar with how we use composition in USD. And you should be familiar with, well, what we talked about last time, which was data and structure. And that should give you a really good understanding of the basics of USD moving forward. Next lessons are going to be about creating assets and about building shots. But in order to do those things, you definitely need to know more about USD composition. So let's spend, I don't know, maybe another couple of hours, potentially more, who knows, talking about USD composition. So these are kind of the three main topics for the first part of this video. Then we're going to talk a little bit about other things related with composition as well. But more about that in maybe an hour or something like that, or an hour and a half. So yeah, first topic is composition itself. We're going to mention a few things. Then we're going to talk about stages, which is also in the context of composition. And finally, we're going to mention a few composition arcs, which are basically the different ways that we have of composing in USD. We will talk about sublayers, references. Both of these are composition arcs for USD. And then we're going to talk about specifiers, which it is kind of like an attribute that belongs to the composition arcs. There are more composition arcs. We're going to talk about that in a minute. But for now, let's focus on composition. I know there is a lot of text here, so bear with me. I know that good designers usually don't use text in PowerPoints or slides, or they use as minimal text as possible. The reason I have a lot of text here is because I just don't want to forget what I want to mention. But I'm not gonna, let's try to skip the text as much as possible. Let's not read all of these word by word. Let's try to kind of summarize this somehow. So let's start with the first bullet point. So USD files, when we talk about composition, what is a composition? Well, usually we start with multiple USD layers or USD files. We saw this the last time. So we can have a USD file, which is a model. We can have a USD file, which is a look dev. We can have a USD file, which is some kind of animation, maybe a USD file that defines the lighting of the scene. and maybe a USD file that defines the render settings of the scene. So we usually work like that, right? With individual USD layers or USD files. So composition, it is, I guess, the method of combining all these individual USD layers to create a new scene description. So each of these individual USD layers, they contain already a scene description. And when we combine all of them, we merge them, so to speak, we create a new scene description. This is the composite or the composition. Okay, so the act of combining multiple USD files, that's what we call a composition. And compositions can be very simple or they can be a little bit more complex. The way that composition works, it is by referencing the content of all these individual USD layers into the 3D scene. And once we're here, well, we can leave it here. I mean, this can be the 3D scene in Houdini Solaris where we combine everything. Or from here, we can actually export a new USD layer or a new USD file if we want to. Okay, but this USD file, it is always going to be referencing every single USD layer. So these are all references. It is important to know that these references are live, meaning that any change that we make in these original layers, it will automatically be reflected down the line. So anything we do here in between to these individual layers, it is kind of procedural because these are using live references. Also, these references that we are creating here, they can be created in any software, and the composition can also be done in any software, meaning that you can do your model in Maya, you can do your layout in Maya, you can do your look dev in, let's say, Katana. Then you might want to do your set tracing in Houdini using scatterers, for example. And finally, you can do your lighting and rendering in Katana. So it doesn't really matter where you do it. The data is going to flow. So we always have live references independently of the software where those original layers are being created, and independently of the software where we combine, where we do the composition of those USD layers. And this is extremely important because there is no other format that supports this. Right now, if we work with Alembic files, let's say we have to bake at some point. So we have a model that we usually bake and we export from Maya to, let's say, Katana. And then we do the look dev, then we export a look file, then we might go to Houdini to do the layout and set tracing, then we need to bake that into another Alembic file, take that into Katana, apply the look dev, do the lighting and do the render. If anything changes at some point, we're going to have to bake new files. So we're not using live references because there is no file format that supports live references in multiple software. You might be able to do that if you only work with one software. Like if you work in Maya, Maya has a referencing pipeline, right? Maya references, they are not great, but they tend to work quite well for many situations. But as soon as you leave Maya, you lose those references. So it cannot work in the same way as USD does work. These live references allow artists to work independently on their stage of the pipeline. And this is very important without the need to bake everything every time something needs to be exported. This is exactly what I was explaining before. You can be a layout TD. You might be working on the layout and set dressing of your shot. And if there is a new model published, well, you just need to, well, actually, you don't need to do anything. Let's say you are a lighter. Let's say you are a modeler, and then your model goes to layout, and then it goes to lighting, right? If the layout is done and approved, but there is a new change in the model, once this model is published, a layout TD would have to open the scene, update the model, and publish a new version of the layout. So lighting is up to date with all the latest. With USD, you don't actually have to do that. If you have a new model, you publish the model, but then the layout TD doesn't even have to open the scene because the layout is not going to change. The only thing that changes is the model. So, you know, there is no need for this layout TD to interfere. They don't have to open the scene and publish a new version. Now, this can go directly to lighting and it's going to be up to date. Because in lighting, there would be a model layer, USD layer, that is going to look at the origin and update the model automatically. So this is, you know, a game changer when it comes to working independently on the different stages of the pipeline. Also, when we're doing compositions, it's very important to note that attributes can be overridden. This is very important because, again, if we're going from modeling to look dev to, let's say, layout to set dressing to animation and I don't know, whatever, right? Like FX and lighting. Well, at some point, if here we were doing the look dev, but when we are in lighting, we feel like a shader needs to be tweaked or needs to be changed. We're going to be inheriting whatever was here in the look dev here, but we can add an override in the middle and change a shader or change some textures or, well, anything can be really overridden, any attribute, not only look dev, of course, but anything that comes from effects, like a density of a volume or anything that comes from animation or anything that is an attribute can be overridden at any time. This is probably what I was mentioning before, right? Like in a traditional pipeline, a model gets exported, then imported into a layout scene, then everything gets baked for lighting. So if the original model gets an update, the layout will be outdated. There is no live references in between those departments. Meaning that the layout artist would have to open the layout scene, replace the old model with a new model, and bake a new layout Alembic. Then lighting would have the latest and greatest, right? But you need that intermediate person to take care of whatever goes in between modeling and lighting. With multiple 3D packages, this is pretty much impossible to fix. Some big visual effects houses might have their own solutions for this, but USD gives you all these possibilities out of the box. That's why, again, in USD, every department will work only on their part without worrying too much about where the dependencies are coming from. At any time, any department can update their part of the shot, and it will be automatically updated without the need of other departments to interfere. This is exactly what I was mentioning before. There is no need for a layout TD to do anything if they are not changing the layout. If a dependency of the layout has been updated, they don't need to worry about it because we have a live reference system that is taking care of all of that. there is an expression that you're going to hear all the time, which is authoring an opinion. That means that a layer has a stronger opinion than the layer before. This is kind of what I meant with overrides, right? You can have a model, you can have lookdev, you can have a layout, and you can have a lighting. Every single of these layers have opinions about attributes. An opinion can be make that object metallic or make that object red. So this lookdev layer would have an opinion on the color of the object, make that object red. This other layer might not have an opinion on the color of the object, so it's going to inherit whatever opinion came from here. But at some point, here, before lighting, we might say, we want to change that object, and instead of being red, we want to make that object blue. Well, we can author a new opinion here, and we can say, this object that was red here, I want to make it blue here. So that would be authoring an opinion, creating an opinion about an attribute or about a component of a primitive. And those opinions can either be by modifying an existing opinion or adding an opinion that wasn't there before. I might have no opinions about color at all in my USD layers. So if I create a new one here, I would be authoring an opinion by creating it from scratch. Whoops, I did this thing here and I don't know how to get rid of that. I think I should have like a eraser. Yeah, cool. All right, cool, great. Okay, so authoring an opinion, it is something that you're gonna hear all the time when working with USD. The final composition, so when we have multiple layers, at the end, this will be kind of like the final composition of our USD tree, if you want to call it like that, or USD layers. So in the final composition, what we're going to be doing is solving which opinions are stronger to take care of any conflicts, right? So if here we have an opinion about color, and here we have another opinion about color, then we have a conflict, right? So USD will wonder, should I listen to this layer or should I listen to that layer? Well, of course, we're going to have rules, right? We're going to have rules. More about rules soon today. So based on those rules, USD is going to solve this conflict and it's going to say, okay, even though this layer is telling me that something should be red, and this layer is telling me that the same thing should be blue, I'm going to listen to this one because I have a rule telling me that this one should be stronger than that one. That's what the composition engine does in USD. Okay? The goal of a composition, it is to combine multiple USD layers into a single final composition with no conflicts. That is very important, and we're gonna look into compositions with no conflicts in Houdini in a minute. For now, maybe let's go jump into Houdini and I can show you something very quickly. Maybe we can do like a very quick composition so we can actually see how live references work. All right, let me have a sip of my coffee. Okay, so here in SOPs, I have 3 props. All of these are from the Animal Logic Labs scene. So if you haven't downloaded that one, let's go and do it now. You should know about this scene from the first video already. So I have this thing called, it is a prop called audio generator. Then we have another one, which is this oscilloscope. And then we have this one, which is a turntable. Three simple props. I mean, we could have used like spheres and cubes, but because we have these assets available, let's use them. So something that I done here, and it is not actually important, but these objects, they are not live geometry. They come as USD. So in SOPs, you have this node called USD import. And this allows you to bring a USD file into SHOPs. So that's what I've done here. I have this USD import. By default, this primitive field, it comes like that, which basically it is going to import everything as it was meant to be used. So in the case of these assets from Animal Logic, they are meant to be used by just looking at the proxy, as you can see here. So what I did is I just selected here all geometries. So now I'm importing the high resolution and the proxy. They are both here. Then I did an unpack USD, which is another USD node. Unpack USD. So basically it's going to unpack this USD import. So now it is live geometry. And now I made a group with the proxy. So now I can just get rid of the proxy with a blast, removing this group. So now what I'm looking here is the high resolution geometry. So this is just, just for this exercise, because I don't want to use the proxy, I want to use the high resolution mesh. Then this comes with many different primitive attributes and vertex attributes and groups and whatnot. So I just created an attribute delete to get rid of everything, and also a group delete to get rid of all the groups. So now this is pretty clean. And I just exported this as BGeo. I just want to start from scratch. So now I imported the BGeo, which is the high resolution mesh. I added a clean to clean all the attributes and all the groups, even though I don't really need it, because I deleted all of these here. So I can basically ignore that one. And then I just created a primitive, an attribute wrangler running over primitives, where I'm basically creating a string attribute, a path. So this is pointing to Workbench, which is the name of the master prop, if you will. Then I'm saving this in a context called prop. And then I'm naming the asset prop audio generator. You already know about this from the first video, so there is no really need to mention anything here. Okay, let's mute these two, and now we have this prop. And I did exactly the same with the oscilloscope, and same thing with the turntable. I just wanted to have clean geometry here. Okay, so now let me go to Solaris. Let me go to stage, and well, I have plenty of things here, but don't worry, this is just something that I had here when I was recording the video in Spanish. So don't worry too much about this, because we're gonna redo all of this now. Okay, so the first thing that I want to do is bring all of that, right? So if I do a SOP import, you should be familiar with this process already. So I'm gonna import my audio generator. Okay, so here we have it, and this is saved in Workbench. So here we have an Xform prim called Workbench, a prop Xform prim, and finally the mesh prim that creates this audio generator. We already have the structure because we defined this structure with the primitive wrangler in SOPs. You already know this. Okay, so let's duplicate that one, and let's bring the next prop and do the same with the last prop, which is the turntable. Right, so if we merge these three, okay, here we have our workbench, props, and then we have the three props that we're using in this scene. So let's pretend that this is the modeling stage, right? So let's write the first USD layer, which is the modeling. So let's use a USD ROP. I'm going to go to my USD folder. I'm going to create a new directory called live English, and I'm going to call this one modeling version 1.usda. And I'm going to save that one to disk. It is complaining, so I'm going to basically flatten all layers. So now it doesn't complain anymore. And we can take a look at that file. Live English modeling version 1. And let me change the format to PixarUSD. So now it's easier to understand. Okay, so we're already familiar with the structure of these USD ASCII files. So here we see some metadata, and now we see what we are defining here. So we are defining an XForm called workbench, another XForm called prop, and then we have a define of a mesh called audio generator, and here we have all the attributes. So these are the attributes of the phase variant attributes. So this is basically like polygons, vertices, and whatnot. And we have the same for the oscilloscope and the same for the turntable. So basically we're defining primitives here. So this is our modeling layer. Okay. Maybe, yeah, let's put this in a backdrop, and we can call this modeling. So now, if we are a layout TD, if we are layout artists, we would need to use this layer in our layout, right? So let's do that by using a sublayer. We're going to talk about sublayers in a minute. So this sublayer, of course, is empty, so there is nothing here. Let's bring the USD layer. So here in File, we can basically take our modeling, and we should have our models. So this is where we're starting. So this is the modeling stage, right? So let's call this one modeling. It's called modeling 2 because I have maybe some other thing called modeling here. So yeah, that's why it's called modeling 2, but you get the idea. So we have our modeling layer. So now as layout TDs, layout artists, we want to start, or set dressing, we want to start like kind of organizing these into the set. Don't worry too much about this node yet, but we're going to be using a layer break. We will talk more about layer break in the near future, but basically this layer break means that if we create a new USD file from here, so if we create another USD ROP, whatever is before this layer break is not going to be included in the ROP. And that's exactly what we want to do in this case, right? As layout TDs or set dressers, we want to organize these props in the shot, but we don't want to author the actual models. We don't want to define the models. We did that in the modeling stage. We did that here. Now we're not modelers, so we don't care about the model itself. We care about the position of those. So let's create a transform. Let's put it here. And let's take, I don't know, the audio generator. Now let's move it here, and let's rotate that one, move it over there. Let's create another transform, and let's grab the turntable and move it over here, and let's do something like that. All right, So this is our layout or set tracing or whatever you want to call it. Now we can save another USD layer. So we can go here. Let's go to USD Live English and let's call this one layout version 1.usda and save the file. Okay, let's take a look at the file. So there are a couple of things that we can see here. First of all, in the modeling stage, we are defining. These are called specifiers, and we're going to talk about this in a minute. So for now, don't worry too much about it, but you can see these are defining a prim. On the other hand, in layout, we are not defining anything. We have something called over that stands for override. Again, we're going to talk about this in a minute. And as you can see, in the modeling stage, we have plenty of attributes defining that primitive, like vertex count, amount of polygons, and so on. In the layout stage, we don't have any of that because that was already defined in the previous layer, in the modeling layer. So the only thing that we have now is transformations, which is the only thing that we included after the layer break. So we are only adding this to this USD file. Okay, so this will be our layout. Okay, cool. Right, so if we are a lighter, we would actually start using those layers that have been published. So we would create, we would create sublayer with the models that have been published. So let's grab our modeling layer. And then we would grab our layout. Okay. And as you can see, nothing really happens. And if you take a look at the SIGGRAPH tree, there is really nothing. There is only these containers. We're going to talk a little bit later about this. But as you can see, when we have a layer that is not defining a primitive, and you saw that one here, we're not defining anything. We're just creating overrides. We only see containers with placeholders, right? We have the same structure that we have here. But here we are defining primitives. Here we're not. And as you can see, this layer doesn't really do anything. You don't see anything in the viewport. That is because it is expecting something to apply these overrides. So as soon as we connect the previous layer, now we get everything that we're expecting. Cool. So if we are a lighter, now we can start working. We have our model layer, then we have our layout layer, and then we can just start, let's say, adding a light. We can take that one here. And what is this? This is a point. So, if we look at Arnold, we should be able to see something here. Maybe the exposure needs to be increased. So you can see, there you go. Okay. So yeah, this is how we're working. Let me go back to OpenGL. So what if the model needs an update, but not the layout? Let's say the layout is going to be the same, but the model is going to change, like removing this handle over there. Well, then only the modeler needs to do some work here, right? So if we go back to shops and we take this guy and enable these couple of nodes, basically I'm getting rid of this handle, right? So we went from handle, no handle, then we would have the modeler exporting a new version of that layer. Did we get an error? Okay, yeah. So now if we take a look at the layout is automatically updated with no handle in this prop, right? So in our case, of course, because we are not working in a automated pipeline, well, we just need to save that thing. But usually, you know, if you have a more developed pipeline and you're not working at home like we are, all of these would be, I mean, once this guy has been published, the layout would be automatically published. So when you are in lighting, you only need to do nothing. And as you can see, everything is automatically updated. So you can see that all of this is working properly and you're getting the latest model. And again, because these layers are actually using live references to the modeling layer and the layout layer, you don't actually need to worry about anything. Everything will be automatically updated for you. So that is kind of how USD compositions work. This is, of course, a very simple exercise. This is the most extremely simple situation, I guess, but you get the idea, right? Everything is live references. So in the layout, we're live referencing the modeling layer, and in lighting, we are live referencing two layers, in this case, modeling and layout. This is how it works. If we go back to our PowerPoint, and now that we understand how composition works, which again, it works by using live references and anything gets updated automatically at any given time. So now it's time to talk about stage. What is a stage? So stage, it's basically like USD compositions are dynamic. What we mean by that is like every time you open a USD layer or a USD file, the composition engine will assemble the scene graph tree using the opinions coming from all USD layers. That's what we saw here, right? When we assemble this scene or these layers, we have a modeling scene that has no opinions about transformations. Then we get another layer called layout, and this one has opinions about transformations. So we get these props moved because here we have a stronger opinion about transformations than the one we had there. Actually, here we didn't have any opinions. So any opinion is stronger than no opinions. But here we could have another layer with even stronger opinions about transformations than the ones we have here. So this would be overridden with whatever opinions we add here. So USD stores the result of a composition in what we call stage. So stage is basically how we refer to the resulting prims after a composition. So these prims, right, they get changed based on this composition. That is what we call a stage. So what we have here, it is a stage. So this could be like stage 1. We might have like multiple layers down here, and that would maybe create a stage 2 that has nothing to do with stage 1. Okay, so this is a really good way of creating what we call sequence lighting, because we can have multiple shots, potentially an entire sequence, in just one single tree, one single scene. This is very important. Stages are not saved into files. So if you take a look at any USD file, there is nothing here that configures a stage. Stages only happen during runtime. That means after opening a USD layer or after opening a 3D scene in Houdini that contains USD layers. This generation of the scene graph, this composition of the scene graph, is done by the composition engine in USD. And again, it only happens once all the layers have been read and composed together. You wouldn't find anything in relationship with the result of a composition in a USD file. That is very important to know. Okay. It is time to talk about composition arcs. What are those composition arcs? Well, in USD, there are multiple ways of combining layers. That's what we call composition arcs. And to do that, we use different operators. It is not exactly the same, but I think I can give you an example that kind of mimics this, even though, again, it's not exactly the same. But if you think about how Nuke works. So in Nuke, you usually have one layer, which is usually a render, and then you have another render. And, well, you can have as many as you want, of course. You can combine these two with a merge node, right? This is a merge. So a merge node can do multiple operations, right? They can do like an over operation. So that would be A over B or the other way around. You can do a multiply. You can do maybe a screen. Or maybe you can just add, or you can subtract. You can do multiple operations with a merge file. The USD kind of works in the same way. You can combine layers using different operations or using different operators. We have all these different operators in USD. We have sublayers, we have inherits, we have variant sets, references, payloads, and then we have something called specifiers, which is part of all these operators. Sublayers and references are the most important ones and the ones you're going to be using the most. Inherits, variant sets, and payloads, they are also important, and we're going to take a look at those, but they are slight variations of sublayers and references. So if you understand sublayers and references, you're probably good to go. You would be able to use inherits, variant sets, and payloads with no problem. So let's take a look at sublayers first and references later. Sublayers. The first composition arc. Sublayers are the simplest way of combining USD layers. It usually works by stacking them on top of each other. Actually, they can be stacked or they can be connected from left to right. We will take a look at this in a minute in Houdini. So sublayers are the usual way of assembling a scene with layers from multiple departments. This is kind of what we saw before, right? Like we have the model layer, goes to the look dev layer, goes to the set dressing or layout layer, goes to the animation layer. It might go to FX layer, then it might go to lighting, rendering, and this might be like a sequence lighting, and then we might have like one shot, another shot, and maybe another shot. So that's usually how we work when we're bringing information from multiple departments to create a shot. That's what we usually use sublayers for that. So again, it works from top to bottom or left to right. So this is kind of how Photoshop works, but inverted. So Photoshop usually works with, we have a bottom layer and whatever we put on top is going to be composed against this layer and so on. In USD, well, internally, USD works exactly the same way. And we're going to take a look at these in a new panel that we have in Houdini called Layer Stack. So internally, it works the same, but when you're working in the scene graph, it actually works the opposite, from top to bottom or left to right. We already talked about these, which is we have different opinions, and some opinions are stronger than others, meaning that if an opinion is stronger than the layer before, it's going to override that opinion and resolve the conflict. But also, if you don't have an opinion in a layer, any other opinion will be stronger. This is very important. We're going to take a look in Houdini now. And the layer stack, it is a new panel that we have in Houdini. In Solaris, we haven't looked into the layer stack yet, so we're gonna take a look at that. And in the layer stack, we can actually see the order of the layers, and we can see how layers are sub-layered. So basically, the result of a composition, whatever we have at the end of a composition, can be looked at in the layer stack. And we also have nested layers. So we're going to take a look at nested layers in a minute, but maybe let's go to Houdini and let's take a look at all of these. So yeah, what we have here, let me get rid of this. We don't need any of that. So what we have here, this is basically sublayers, right? So basically we created a sublayer, and in this sublayer, we got the modeling layer, then we got another layer, which is the layout. And then here we could have, let's do this. Let's create a layer break. Let's take this light, and I'm going to place this light inside of Workbench as well. So I'm going to do Workbench. So now we have lights and props, and in lights we have this light. So if we create another USD prop and we save this one as, let's say, lighting version 1.usda. Okay, save that one, and let's take a look at that layer. Houdini, USD, live English, and here we should have a lighting USD layer. And as you can see in this USD layer, we don't really have anything above the lights. So here we are defining a light group that it is defining as sphere light called light 2. And here we have all the attributes for that light. So you can see like the exposure that is 15 and the intensity that is 1. I think those are the only things that we actually change. So all of these are given attributes. Okay, so again, if we are working on a sequence, we would be sublayering all the information. So we can take all the assets that go into the shot. Then we would take the layout, and we would take the animation effects, set dressing, I mean, anything that contributes to the shot. In this case, we only have this lighting, which might be the sequence lighting. So yeah, this would be our shot. So if we take a look at Arnold, the light should be working on everything, right? We have the light, yeah. Okay, and this is how the render looks like. Okay. Right, and anytime we can override any of these attributes that we have here. We're not going to be doing that now, but we will a little bit later. Right, so let's imagine that this is our sequence lighting, right? So everything that belongs to the sequence is here. So this is our assets, our layout, and our lighting. If we save this into a USD ROP, and we call this one, let's say, sequence version 1.usda, and take a look at that sequence thing. So you can see here now, we don't really have anything here. We only have layers that we are using this sequence. So as you can see, we have the sublayers called lighting, layout, and modeling. And all of these, again, they are live references. So if our sequence lighting gets updated, if we take this light, put it here, we move it over there, maybe we change the color to blue, and this one we change the color to red. So now we have this thing here. And if we write a new lighting USD layer, of course, it gets automatically updated in our sequence lighting, right? We haven't done anything at all. Everything gets automatically updated. And if we write this file, again, this is just how it looks. We just get these layers that, again, they are being referenced from here. In the same manner, if we change anything in the layout, let's say if we go here and we add a grid and we merge it here, if we do something like that and we write this layout, if we take a look at the layout file now, before we didn't have any definitions, it was all overrides, and now that's what we have, but now we're adding a definition prim here because we are creating a grid. Of course, if we go to our sequence lighting, now we have the grid there because this, again, this sequence lighting is looking at the layers, and these are live references. And again, these could have been done anywhere. Could have been done in Maya or Katana or any other software that supports USD, that our composition will work with those live references anytime. Okay. Right. So yeah, this is the most common way of sublayering. There is also the possibility of sublayering from left to right instead of top to bottom. Oh, but by the way, let me show you the layer stack. So if I select the root here and I go to layer stack, here we can see all the layers used in this composition. So we can see like the modeling is on the bottom. So this is what I was saying before, that this order is kind of inverted because this is the modeling, which is on the top, but here it is on the bottom. So internally it works like Photoshop from bottom to top, but here in the stage 3, it goes the other way around. So yeah, we have the let me take, where are we? Here. Okay. Go. Yeah. So we have the modeling on the bottom, then we have the layout with opinions stronger than the modeling. Then we have the lighting with opinions stronger than the other two layers. Even though in this case, we don't really have opinions affecting the layout or the modeling because the lighting USD layer is only creating lights. But we could have any opinion here to modify or to override whatever we have in layout or modeling, which is not the case in this case, but you get the idea. So yeah, this is the layer stack, and you can see how layers are being used in any of these prims. So I'm just selecting the root, so that's what I'm seeing everything. But if I select the props, we don't see any lighting layer because the lighting layer is not really affecting the props. So for the props, we only have modeling and layout. And if I select the lights, we only have the lighting USD layer. There is also a way of using sublayers from left to right. So if I create a torus, so let's create a torus that is like the radius is 1, and maybe we can go inside and add a color. Oh, by the way, as you can see here, I'm using this shop create. So this would be the same as going to shops, creating a torus here, and then shop import this into lobs. That would be exactly the same, but without the need of doing that. But internally it's doing the same. So when I go inside, as you can see, I'm in shops now. So let me just add like a, let's say, red color. So now we have this red torus. I'm going to duplicate that one. And in this one, I'm going to remove the color. So we have a red torus with radius 1 and non-colored torus with scale 2. So yeah, this is one torus, this is the other one. And I'm going to keep this one in assets, torus, and same here, assets, torus. So if we take a look at the scene graph, we have assets torus and this one asset torus. Okay, so here we have a conflict, right? Because we have one torus called torus mesh 0 and this one torus mesh 0. Both of them, the namespace, the path is the same for them. So there is a conflict. So we can create a sublayer and we can connect this one on the left, that one on the right. And it is complaining. It is complaining because this is expecting a file, as we did here, right? Like these are using files. But if you are connecting anything here, it will expect, instead of sublayer files, it would expect inputs. Okay. So what's going on now? Now we have, again, this is torus radius 1, torus radius 2, no color, and red. How is this resolving the conflict? Well, it is creating a torus that is red with a radius of 2. Why is that? Well, because this torus has a stronger opinion over that one because it's connected to the right. So this is radius 1, this is radius 2. There is a conflict, and because this one is connected to the right, the conflict gets resolved and it is using the strongest opinion, which is this one. That's why the torus radius now is 2. But on the other hand, we have a red color, which comes from here, not from there. Why is that? Well, because this torus doesn't have an opinion about color. And remember, any opinion is stronger than no opinion. So here we have an opinion saying this is red, and here we don't have an opinion. So the strongest opinion for color comes from here, but for radius comes from here. If we add a color here and we say green color, now this one has two opinions stronger than this one. One is the color and one is the radius. So this one is radius 1, color red. This one is radius 2, color green. So when we layer them, this one wins. Okay. And yes, this one can be used also with these things. So here we have the model. We can connect that one there. Here we have the layout doing nothing. Well, actually it is creating a grid, but it is doing nothing to the actual props. So when we connect that one there, this opinion is stronger when it comes to transformation of the props. So we're going from here to there. So this is how we use sublayers, from top to bottom or left to right. And yeah, anything that goes after the previous layer has a stronger opinion, or anything that gets connected to the right has a stronger opinion than the one connected to the left. And we saw the layer stack, right? Remember that the layer stack is here, and it shows you from bottom to top the order of the layers that you are using. Also, nested layers. Those I showed you that already in the sequence lighting USD layer. So those are layers that contain multiple reference layers. So again, if we go here, we have a sequence lighting USD that contains these 3 layers. So if I only have these sequence layer file, let me find it, sequence, there you go. So if we have this one, if we go inside, you can see that in the layer stack, we can actually see all the multiple layers that belong to this sequence version 1 USD layer. So yeah, this is the layer that we have here, but it has nested layers, which is lighting, layout, and modeling. They are nested inside of the sequence layer, and it is referencing these 3 other layers. So as you can see, this is extremely powerful. And again, everything is live references. This is actually quite important. Sublayers are the only composition arc that can be muted. This is very important, especially when we're debugging a scene or we want to mute something and not render that. We can mute the content of a sublayer. Well, actually that's wrong. Not the content of a sublayer, but the layer itself. We cannot access to individual prims inside of a sublayer, that we can mute the entire layer. So if we go back to Houdini, I can use something, we're going to look into this a little bit later, but if we use a configure stage, so here we get a stage, right? Remember, a stage is basically the resolution of a composition when all the conflicts have been fixed. So yeah, here we have a resolution. Here we have a stage, a final composition that is using modeling layers, layout layers, and lighting layers. With this configure stage, we can go to mute layers. We can click on set layers to mute. We can click here, and now, because here we can access to all those layers, we can mute whatever we want. So maybe we say, you know what, this lighting doesn't really work, so I'm going to take the lighting and I'm going to mute it. And as you can see now, I don't have a lighting. But I can just remove it, and now I have the lighting back. Or maybe I say, you know what, this layout is not really working, so let me remove the layout and I will do my own layout here, and I will export a new USD layout layer. So I can just come here and say, layout, you're not working for me, mute. So I don't have the layout, but I still have the modeling and I still have the lighting. So this is quite important, but again, only sublayers can be mute. But again, you can only mute the entire layer. So if I want to mute, let's say I have 2 lights here and I want to mute only one of those lights, I cannot do that. I cannot access to the prims that belong to the layers. I can only mute the entire layer. There are other ways of doing what I just said, and I'll show you later. Oops, what is this thing? Here, okay. Sublayers are the most efficient composition arc, so it is the fastest because it doesn't care about prims, it only cares about the content of the layer, so it is very fast and very efficient. That's why we use them all the time to build shots. And this is also very important, sublayers cannot be layered more than once. So if I take, let's say, my modeling, let's say I'm doing set dressing and I say, you know what, I want to move this turntable into, or I want to copy it 5 times because I want to have the turntable in 5 different positions in a room. Well, let's do this, let's move it, and then let's duplicate this one And because I'm again using the modeling thing, and let's take the turntable and move it somewhere else. Once you connect them, you get an error. I don't know if it says something. Yeah, it says cannot add or duplicate the sublayer. So sublayers cannot be layered more than once. It doesn't work, it errors. And that's because you have a different composition arc if you want to do that. And those are the references. Okay, so references, they are used to assemble individual assets into sets and scenes. Just exactly what I just mentioned, right? If you want to take that turntable and you want to add it on top of a table, and then you want to move it into a shelf, and then you want to add that to another table, and then to another shelf, those are things you can do with references, but not sublayers. The reason why is because references, on the contrary of sublayers, you can specify a prim on a layer and attach it to the current layer. Okay, so you can say you can have a layer that contains the turntable, the audio amplifier, and the oscilloscope. If you have this in a sublayer, you're going to get the three of them. But with a reference, you can say, you know what, I don't care about this, and I don't care about that one. I only care about this. So let me take this one and attach it to my current layer of working. That's where you use references. Yeah, exactly. That's what I wrote here, right? Like instead of all the content on a layer, like sublayers, references can pick and choose the content of a layer. So those are great. Not only that, but you can also rename prims. So you can have a turntable here called turntable 1, but in your layer you can rename that one to turntable old or turntable new or whatever you want to call it. So yeah, you can duplicate a prim as many times as you need because you can rename it. Also, references can be layered as many times as you want. You can duplicate a reference node many times. That's all good. That's why they are great for building sets and shots. So they are great for layout and set dressing. For anything that is building an environment, they are just great. And of course, then you can bake in a way a USD file with all that content, but it is not really a bake, it is a live reference. So, they are great for that. And this is very important. References basically create pointers. So they don't really create anything, just pointers, something that points to something else. They don't import the geometry, they just point to a geometry that lives somewhere else. So basically, yeah, you get the content of a layer and attach it to the composition, but it is a pointer to an existing geometry that lives somewhere else. Well, I'm saying geometry, but it can be actually anything. So yeah, this allows you to modify the content of a layer and update it only at composition time. So let's maybe take a look at that. So now instead of sublayers, we already know how sublayers work. Let's take a look at references. So it is a node called reference, and actually if you do a file, this will give you a sublayer. And it is exactly the same, right? So you can create a sublayer or you can create a file. It is the same. And as you can see, when you create a file, it says that is a sublayer. So reference, again, it is the same. You can also read USD files, but they are not sublayers. So if I go here, let me go to my utils, animal logic. There you go. So here are all the assets downloaded from the animal logic scene. So if I go to entity, I have all the USD assets here. So let me take whatever, like these books. I'm going to go to modeling, and here I have these books. And as you can see, these books, they live here. This is the structure created by Animal Logic. I haven't changed anything at all here. So where do I want to save this? Well, let's call this one library. And then here I can call this one, well, I can rename this one to box but I already have books somewhere else in my scene. So let me just name it here, books. Okay, so now we have a prim called library, a prim called books, and then inside we have geo, proxy, and here we have the geometry, and here we have the proxy. Okay, that's great. So what can we do here? Yeah, let's do this. So I'm going to duplicate that one, and now I'm gonna maybe select a different asset. So let's select these magazines. There you go. And these, instead of books, let's call this one magazine. Okay. So if I combine these two, I have a scene graph tree here that contains, it is a library, books, and library magazines. Okay. So yeah, we have both the books and the magazines. Let's take the magazines and move them somewhere. So I'm going to do a transform, and I'm going to take my magazines and move them maybe here. So I'm doing my set dressing here for my environment. So this is a library. I'm doing my set dressing. Okay. But now what if I need, I don't know, maybe 3 of these magazines? Well, I can just duplicate this layer and connect here. And now I'm not getting an error. Now I'm getting these magazines. Let me detach it so we see where we are. We are there. And let me rename this one to magazines 2. Okay, because yeah, there was a conflict with the name, of course. Right, so they are there. Just to make it a little bit simpler, because maybe I want to select only 2 magazines. So I'm going to disconnect this so it's easier for me to see this. So in this reference, now where it says reference primitive, it says automatically, or you can say default, and this is going to choose whatever it was exported as a default, or you can just set reference specific primitive. So basically I'm going to select maybe this one. Okay, so now I only have one. Maybe I want to select another one. So let me copy this path, create a new reference, paste it here, and let me select maybe that one. Okay, and maybe another one, specific primitive, and maybe that one. Okay, so I have 3 instead of all of these that I had before, right? Before I have all these magazines. Now with a reference node, I can pick and choose the content of a sublayer. Now I can put those there. Now I can add a transform, and now I can take these magazines too, and maybe move them somewhere here. Okay, so as you can see, I am creating my set dressing using all those things. Okay. Right. So now from here, I could do like a USD ROP, and maybe I can save this one as set dressing. Okay. And if I take a look at my set dressing, this is what I have. So as you can see, I'm live referencing these USD layers. And the only thing that I'm actually authoring, the only opinion that I'm creating is this transformation here for these 3 magazines and that one there. But I'm always using these live references to other existing USD layers. So if at any time the modeler changes the model of any of these books or any of these magazines, my set dressing that I'm making here, it will be automatically updated, and I would have to do absolutely nothing. Okay. So yeah, this is how references work. So that is pretty much the main difference between sublayers and references. With references, you can pick and choose the content of the layer, and you can rename it. As you can see here, we rename everything. We rename prims. We rename anything you want to rename. You can basically do it here, and you can duplicate it as many times as you want. So yeah, great for building sets. Okay. And yeah, this is the last the slide of this first chunk. We're not done with today's video. Still plenty of things to cover, but this is the last of this chunk, which are the specifiers. And you've seen this already, but maybe we need to go through it once more. So the specifiers are basically what defines the composition arcs. So we have the def specifiers, that stands for define. And define is basically when you are creating a prim. And this is the default specifier. Prims with a define specifiers will be rendered. So again, when we were creating in the modeling stage something, we were creating these props, we are defining them. So if we take a look at the modeling USD layer, we are defining a prim. We're defining an X form, we are defining another X form, we are defining a mesh. So we are defining, and all the attributes are being created here. So this is a define specifier. On the other hand, when we were doing the layout, we started with the models, and then we moved those things. So here we're only authoring an opinion about the location of those props, but we're not defining the props themselves. The only thing that we're defining here is this grid, right? Because at the end we added a grid. So this grid, yes, we are defining it, but these other props, we didn't define them. We just added an override. So that is the second specifier, that is called over, and stands for override. So it creates a speculative prim container. It creates a container only used to override opinions, in this case the transformation of the props. It will work on top of a defined primitive, and its opinion will contribute to the stage. Okay, so in order to work, you need a defined primitive first, and it will contribute to the stage, to the final composition. If a prim only has an override specifier, it will do nothing. We saw that before, right? But we're going to take a look again. So override, it is the weakest specifier. It does nothing if there is no a defined prim before it. Any other reference set to define or class will be stronger, right? Remember that when we did the torus, right? We had this torus here. Let's change these inputs again. So if in here we don't have a color, even this torus being stronger because it's connected to the right, if it doesn't have an opinion, this one will win. That's why this one is red, because this one doesn't have an opinion because it doesn't have a color. As soon as it has an opinion, this one will win. Okay. Cool. So yeah, if we take a look at the layout again, this one has a define, a specifier called over, that stands for override. If we take, where is it? Yeah, it is here. So if we disconnect the layer that is defining the prims, this one does nothing. Well, it does create the grid because the grid has been defined, but as you can see, the props, they do nothing. So actually, if we take a look here, yeah, here we see the prim that has been defined for the grid, but for the other stuff, we only see containers, right? Remember what I just said. They create speculative prim containers. So it creates containers with the same structure that these define, right? Workbench, prop, and the name of the props. So we have workbench, prop, and the name of the props, but it doesn't really do anything. And the reason we only have 2 props here instead of 3 as here is because we only author opinions for 2 of them. We only move 2 of them. The one in the middle remains in the middle. So of course, this one doesn't really add anything. So as long as you disconnect it, you only see the containers. It's very important to see that when you select a layer, if you go to the metadata, you can see the specifier here. So you can say specifier, this is a definition or a defined specifier. When you select the layout sublayer, the specifier now is over, because this one, it is an override. But as soon as you connect this one disappears and it's set back to define, because the combination of these two, they work as a stage. They resolve on stage. So here you have the final output, and this is a defined specifier. That's right. And finally, we have a class specifier. So a class specifier, we haven't seen this one yet. We will soon. Okay, so don't worry too much about it. I'm not going to show you an example just yet. But this one tells USD that we're going to create a prim that other prims are going to inherit from. It is an abstract representation and won't be rendered. So an example of this would be a proxy, right? So you have a proxy, and then you have a high-res mesh. So the proxy would be an inherit, meaning that the high-res is going to inherit this proxy. It's going to use this proxy somehow. For example, for viewport visualization, but it's not going to be rendered. So, that is a class specifier, and we use it for many other things, and I will show you some examples a little bit later. But for now, this is kind of like the first part of this video. So yeah, I know, I understand all of this is quite boring, and it is a lot of text, and it's very dense, and it's not, fun at all. But you need to understand all of this before moving forward. So if you need to watch this video again, I know you don't want to, but if you need to watch the video again because something is not clear, let's go back and watch it again, and make sure you understand everything before moving forward with this video. All right, let's continue talking about composition arcs. This was the last thing we mentioned, and this was the last time that I was recording a video. For you, of course, it would be all real time, I guess. But for me, it's been like a week or two. So this is next. So far, when it comes to composition arcs, we talked about references and we talked about sublayers. And again, I think I mentioned this before. These two are the most important ones. You're going to be using all the time sublayers and references. But there are other composition arcs that you might or might not use that often, but some of them are actually quite important. Like payloads, you're going to be using them a lot. And variants, you're going to be using them a lot. Inherits and specializes, maybe not that much, but it depends on your pipeline. I'm going to show you a couple of examples in a minute. It's a little bit hard maybe to understand inherits and specializes. It is actually hard to explain them as well, but I'll try to do my best. But payloads and variants, they are quite important. And I think I mentioned this before, like all of these are actually slight modifications of references, right? So now that you understand references, shouldn't be too hard to understand this. So let's start with payloads. So payloads it is the same as a reference, but they can be loaded and unloaded at any given time. This is what we call differs loading. It means that it doesn't load any data in memory until it is explicitly specified or needed by the render. This is super important. Deferred loading, it is something that probably Katana implemented a while ago, and that's probably why, well, among many other things, but that's probably why Katana became like the standard scene assembly in the visual effects industry and the feature animation industry. Because again, among many other features that Katana brings to the table, differs loading was quite important. That's why it was really fast it is really fast to work with Katana, because you don't load anything in memory until it's needed for the render or it is specified by the user. So you can have huge scenes in Katana and they can run really fast because nothing is loaded in memory. So this is probably what other DCCs or 3D application lacked. So for example, if you have a huge scene in Maya where you have imported like hundreds of models, and imagine that you have a city, right? It becomes really tedious to work with that in Maya because everything is loaded in memory. Of course, there are tricks. You can hide things in the outliner, and that is going to speed things up a little bit. You can work with GPU Alembic caches. That is definitely way better than working with just regular geometry in Maya, but still can be really, really hard to work with all of that in Maya. And Maya is actually quite good when it comes to dealing with a huge amount of memory, but other 3D applications, I mean, if you work with 3D Studio Max, I remember back in the day working with 3D Studio Max, that was completely impossible. Blender, I'm not really sure, but sometimes when I use LiDAR scans in Blender, it was extremely painful and really slow to work with. So I can imagine that having a huge scene in Blender would be also really pain in the neck. But you know, I'm just dumping thoughts here because I never worked with a big scene in Blender. But based on working with Blender with large quantity models, it's quite small, quite hard and quite slow. So I assume it's the same. So yeah, payloads, the only difference really between references and payloads, it is that payloads can use defer loading. Then that is a big thing. Because of that feature, payloads are used for building large sets or big effects data, or anything that is big, really. It doesn't really have to be geometry or effects. It can be anything, like, I don't know, whatever, particles or anything that is big. Most of the time, I would say you're going to use payloads for geometry. So once you create a USD asset, I mean, right? So you would have, let's say this is your geometry, right? Your USD layer that contains geometry. Then you might have another USD layer that contains the look dev, right? And then you might have another USD layer that contains layout, and so on. You would set this layer to be a payload, because in this tree that you have here, most likely the geometry is going to be the heaviest part. So it is a really good habit to always set your geometry layers to be payloads. Then can be loaded or unloaded in memory at any time in the pipeline or through the pipeline. Okay, cool. I'm going to show you how to do this in a minute. A really good visual cue is that in the not the speed tree. I've been working quite a lot with the speed tree lately, but I meant the scene graph tree in Houdini. It shows you payloads in an orange color. Usually references are green. The name of the reference prim in the scene graph tree is green, but payloads are orange. So it's quite easy to see if you have a payload or a regular reference just by looking at the scene graph tree. And then you would use a node called configure stage that I showed you before. Remember that you can use configure stage to mute layers in a USD file, but you can also use the configure stage node with payloads to actually decide if you want to load or unload some of the content of that geometry or that prim in memory. So let's take a look at that. So I'm here in Houdini now, and I've created in advance a lot of things here because otherwise this would take me very, very long to do it live. And it is actually kind of duplicating everything like 10 times. So I'm going to go through everything, explaining to you the different stages, and hopefully you can understand what I'm doing here. So I got this model again from the Animal Logic USD package, which is essentially, remember that I've done this before, right? We have a USD import where I'm importing an existing USD file, which is this one here. I'm just kind of reconverting this to USD with my own standards. So it doesn't come with everything from whatever Animal Logic did to this model. So then you can use unpack USD. Unpack USD. This one will unpack the USD, and then you would have like access to the full geometry. Then I'm creating a group where I'm pointing to the proxy, because this guy comes with a high resolution mesh and then with the proxy, but I don't care about the proxy in this case. So I'm just creating a group with the proxy, and then I'm deleting or blasting the proxy, so I end up only with a high resolution mesh. Then this one comes with a lot of attributes, as you can see here, and I don't need any of those attributes. So I'm just using an attribute delete, deleting everything. And I'm also using a group delete, deleting everything. So I don't have any groups. So I end up with a very clean geometry. The only thing that I'm not deleting, it is the color, the CD attribute. And yeah, writing this as a PGeo. So now I have a geometry. And then what I did here, I'm just reading that geometry, and then I'm creating groups, one for the actual head of the mannequin, another one for the helmet, another one for the antenna. And then I'm just using a primitive wrangler. I showed you how to use this before, but basically I'm creating a string attribute where I'm storing this somewhere in my hierarchy. In my case, workbench, which is the name of the scene, prop head geometry, head geometry. And same for the other one, but this one is called helmet geometry, and finally antenna geometry. And this goes into USD. I created this LOP network, which is basically LOP network, right? You can have as many LOP networks as you want. You don't have to go to stage and have everything here. You can have as many LOP nets as you want here in LOPs, and then you go inside, and then you have your LOP network. You are in LOPs. So I'm going to switch my desktop to Solaris. And this is what I have. Okay, as simple as that. So let me show you this thing here that I have, and we're going to go through all of these. Oops. So what I have here is some kind of a pipeline with all composition layers. So here we have sublayers that you already know. Here we have a combination of references and sublayers. This is probably what you're going to be using the most. Then here we have payloads, we have variants, we have inherits, and we have specializes. Again, all the composition arcs, references and sublayers that we saw here, and the new ones here. So I'm going to go through all of that in Houdini. And what I created is like different steps of a pipeline. So the modeling department, the look depth department, the layout department, the animation department, and the shot building department, or you could call it lighting or rendering or whatever. I just call it shot, but you know, naming of course depends on the studio, or you know, the pipeline that the studio is following. Everything is in one scene here, so I don't have to jump in between scenes. But of course, if you're working on a pipeline in a visual effects studio or on a feature animation house, well, of course, it would be a different scene per department, right? Because every single of these steps, modeling, look depth, layout, animation, would be done by a different person, right? But yeah, for simplicity, I just put everything into the same scene, so it's easier for us to understand. So let's start with sublayers, and you know this already, but I will go through it again. So what I have here is a sub import. So when I import from subs this asset, this is what I get, what I established in subs, right? So we have a prim called workbench, which is just an Xform prim. Remember that Xform prim is just a container, right? The type of prim, or the class, it is just a primitive. Then we have another prim that is the prop head. That's the name of my asset. All of these come from subs. And then I have another prim, which is the geometry. And then I have 3 prims, and these ones are mesh prims. And this one is the antenna geo, the head geo, and the helmet geo. That's what I have. What do I do next? I write this as a USD file, which is prop head modeling version 1.usda. So let's take a look at that file before moving forward. So if I go to USD, what was the name again? Prop head modeling version 1. Prop head modeling version 1. This is the one. Let's take a look. I have a lot of things open here, so let me close all of these. And remember that with Sublime Text, you can go here and change this. Instead of plain text, you can use Pixar USD, and this is going to format the text based on USD, which is great. So nothing new here. I mean, so far you should know all of this, right? So what are we doing here? We have some metadata. Sorry about that. That was my dog barking in the background. I will try to edit this, but chances of me forgetting are quite high. So I apologize in case you are listening to this. Anyway, here we have some metadata about that USD layer. And then here is where we start. We're starting defining our prims, right? So we have a define prim, which is an Xform called workbench. Then here we're defining another prim Xform called prop head, and defining another Xform prim called geometry. Here we're defining a mesh prim called antenna geometry, and here we have all the attributes that belong to that mesh prim. So we are defining phase varying, which if you remember, those are the polygons, the vertexes, and then we are defining also display color, which is the CD attribute or the color of the mesh. And that's it, basically. So yeah. Then we have the same for the helmet geometry. Again, defining the geometry itself and then color properties, and same for the head geometry. Very simple. We already know this. Go back to Houdini, and then we start working in the next department, which is the look depth department, once we have the model. So what do? Well, we create a sublayer. Okay, the composition arc here is a sublayer, a regular sublayer. You know how to use this one already. So the sublayer, nothing is being done here. The only thing is that you are pointing to the USD layer that came out of the modeling department. Okay, so when you bring this one in, you get exactly the same structure, same type of prims, same everything, because all of that was defined here. So if I click on this node, I get this. If I click on the sub layer, importing that layer, I get exactly the same. Nothing has changed. Perfect. So here we're going to be doing some look depth, which for now is actually not true. We're not doing any look depth just yet. We're just doing like changing colors, right? Pretending that that is look depth, but you know, it is not. It's just changing colors. But for our case, it's fine. I just want to show you how to use how to change data in all the different departments. So the first thing we do is creating a layer break, right? A layer break. This one gets connected here and back into the tray. That's it. I don't remember if I explained a layer break before, but basically a layer break tells USD to not include in the new USD layer that is going to come out of the look depth anything that is before the layer break. So this, which is the model, is not going to be included in the new look depth layer because we're not tweaking the model here. We're just changing the shaders. So what I'm doing now is adding some look depth, quote unquote, again, because it's not really look depth, just changing colors, but I'm just adding a color to the skin, color to the helmet, and a color to the antennas. Right? And I'm doing that using the edit properties node. If you don't know what the edit properties is, it's basically this node, edit properties. You connect it here. And now you can change anything in the prim. So for example, I can take my head, drag and drop here, and now I can click on edit properties. And now I can access to any USD property of this prim category. So I can do, you know, whatever that belongs to USD is here. And it's using USD naming convention, not Houdini USD, not Houdini naming convention, but USD naming convention. So if I want to change the color, for example, I would take my display color, move it to the right, accept, and now it should be available here. So if I change that one to red, now I'm changing the color. But I could change anything. So I'm doing that for the head, the helmet, and the antennas. And then I'm writing a new USD file, which is called prop head look depth version 1. Let's take a look. Prop head look depth version 1. Okay. So what are we doing here? Same thing, some metadata. And as you can see here, now we're not defining anything. All these are overs. Remember about that, right? I hope you do. Like, let me go back to here. This was a while ago. Yeah. So the specifiers, we have these three, right? We have def, define. This is what we use in modeling. We are defining a modeling because we're creating something from nothing. Then we have overs or overrides, which are specifiers that do not create anything. They just modify something existing. That's why we're overriding. And then we have class that I explained a little bit before, but not much, but I'm going to explain now. Right. So yeah, here we are not creating, we're not defining anything. We're just overriding a display property, a display color that was already there. So we are overriding the head geometry prim with this color, the helmet with this color, and the antenna with this color. Okay, cool. So that's the new USD layer. And again, we're always working with sublayers. Then we go to layout. And in layout, we have a first layer, which is the modeling layer. Then we connect that one to the look dev layer that we exported here. And then we get the look dev properties. Then we do a layer break. Again, telling USD that this is not going to be included in the new layout USD layer. So what do we do here? Well, this is layout or set dressing, so let's move things around. So I'm going to move that helmet and I'm going to move this thing. Okay, so we went from here, which is the look dev, to the layout, which is this thing. And we export a new USD layer, prop head layout version 1. Let's take a look at prop head layout version 1. What do we get here? Well, kind of the same as the look dev layer, right? We haven't defined anything. We just change position. We just change transformation of prims. So of course, we only have a specializer called over. So we are overriding something that was already there, which was the transformations. So this is the new transformation for the head. We have another over with this transformation for the antenna and another over with this transformation for the helmet. Okay, so that's my layout layer. Then we go to the next department, which is animation. Could be FX, could be anything really. I mean, any department that comes after layout. And what do we have here? Well, now we have 3 sublayers. We have the modeling sublayer, we have the look dev sublayer, and then we have the layout sublayer. And from here, we start animation. So we do a layer break. So none of these gets included in the USD layer. And we do some kind of animation. So what am I animating here? I'm just adding a transform. I'm adding the entire prop head prim, which is this one, right? So I just drag and drop that one there. And then I'm doing, this silly animation. Don't judge the quality of, how things look at this point. I just want you to understand the logic behind USD before doing anything that, looks like anything. And then we write another USD layer, which is prop head animation version 1. And you probably are expecting something here, right? So if we take a look there, we get exactly the same as before. The only difference, and when I say the same, I mean metadata, and then we get that over specialize. Because again, we're overriding transformations, and transformations were defined very early on in the modeling stage. So we have everything we need here. The only difference is like now this one is time samples. Remember when we talked about time samples or default? Default were basically non-animated attributes and time sample were animated attributes. So here we get all the animation for the 72 frames that we have in Houdini. So this animation is 72 frames. So for every of these frames, we get transformations, right? That's it. That's the only thing we've done here. Then we move to the next department, which might be the shot assembly department. So here we get our modeling layer. Then we get our look dev layer. Then we put on top the layout layer. And finally, the animation layer. So what we get here is basically all of these departments combined. And again, it depends on the studio you're working at, but yeah, most studios have something called shot assembly, which is where you put together everything that is needed for lighting, and then you do the lighting afterwards. So this is going to be exported in this new USD layer, which is called Shot 01 version 1. So here we haven't done anything really. We just put together all the content that is needed for rendering this shot. So if we take a look at Shot 01 version 1, this is what you get. You only get these links or these references to existing layers: the modeling layer, the look depth layer, the layout layer, and the animation layer. And the order is from bottom to top, meaning that the one in the bottom is weaker than anything on top. That's why, well, the modeling gets some colors here, it gets some transformations here, and even more transformations in the animation layer. That's the only thing you get. You are not really doing anything in the shot context layer, you're just combining everything together or assembling everything together. And if I create a new reference node and I bring this layer, I get everything, right? In just one layer. I get everything here. My scene graph shows me everything, and my viewport shows me everything. Okay. If I select shot A, right, this is pointing to this file that we exported here. And by the way, this is called shot A because that's the name that I'm using here. And this one is set to OS. So of course, if I call this one hello, this is going to be called hello. And then it's going to contain the prop head and everything that was established before. So let's call it shot A again. And this is how it's called now. So if I was the lighting department, now from here, or here, right, I could start my lighting. So here I have my shot assembly, and from here I could do a layer break, and I could start, let's say, adding a dome light. And if I go to Arnold, now I'm seeing my lighting, and I could work on, you know, whatever, my lighting, I could use my render properties. Well, that was Karma, but I could use my render settings. I could start kind of working on my lighting and rendering, basically. I'm not going to do that now. But the idea behind all of this is like we are using sublayers for everything. And let me grab that one again. Okay. So the goal is like once you have the final sublayer with everything that belongs to your shot, this is all live, right? Remember that this layer is just pointing to these references. So if at any given time, anything is changed down the line, if the model gets updated, the look depth gets updated, the layout gets updated, or the animation gets updated, you as a lighter, you don't have to worry about anything because this one is pointing to live references to all the layers in the pipeline. So as a lighter, you don't have to do anything. You know, you might get an email from the modeling department saying, hey, we changed the head of the model. So you know you need to render a new version, whatever, but you don't actually have to do anything in your scene. Or even if you don't get an email, when you come next day to the office and you open Houdini, everything will be updated automatically without you having to update anything in your scene, in your shot, in your lighting scene. Okay, cool. So this is how you work with sublayers, but you knew that already. So now let's take a look at how we can combine references and sublayer, right? Because here we only use sublayers. So when it comes to references and sublayers, well, you remember that references, if we go back to here, remember that the big difference between sublayers and references is that references are usually used for, where is my pen? Are usually used to assemble individual assets into scenes, right? Because references allow you to target a specific prim and attach it to the current layer. With sublayers, you cannot do that. With sublayers, you get everything that comes with the layer. With references, you can kind of pick and choose, right? And also, you can, I think I wrote this somewhere. Let me see if I can find, yeah, here. With references, you can layer as many times as you need. So if you have a city with 10 cars and those are the same model, you can just duplicate those references and attach them in the same layer, and then you have 10 cars. With sublayers, you cannot do that because with sublayers, you cannot duplicate them, but you can with sublayers, sorry, with references. So the modeling department starts exactly in the same way. You get your model from SOPs with your structure and you write the USD layer. So this is the same as before. Okay, so we have this prop head modeling version 2. Let's take a look, but it is exactly the same as before. So modeling version 2. This is how it looks. Oops, where is my Pixar format? There you go. It is the same, right? We are defining all the prims here, defining geometry, defining antenna. Here we have the geometry, blah, 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 blah. So here we are defining the geometry. Same as always. I mean, you always start defining in modeling. Now, when it comes to lookup, look at this. We are not really, bringing the modeling layer as USD as we did here. Here in lookup, we started with this layer, then we did a layer break, and then we started modifying the lookup. When we work with references, we actually create only the shaders without them being attached to anything. So to do that, I just created a material library, right? So this material library, if you go inside, here you can create your materials. So I'm going to create an Arnold material builder, and I can call this one metal shader, and I can have another one that I can call plastic shader. So look at that. So I have this material library. If you look at my scene graph tree, I have something called materials with the two materials that I created. So I don't remember what I created here. Yeah. So here I have something called materials, and then I created a material for the antennas, and material for the head, and a material for the helmet. And the only thing that I have in my scene graph tree is something called materials. In the modeling department, the only thing that I had is something called geometry. Not the name of the asset, but just geometry. So basically I've done that in SOPs. So I have this prop head 1, and that's what I did in these guys. So instead of having, remember that before I have the whole structure of the asset, like workbench, prop head, geometry, head. What I've done here, and this is most likely you're going to be working like this. So I just have something called geometry, head. and here something called geometry helmet, and here something called geometry antenna. So yeah, take a look again. In modeling, I only have geometry, and in LookDev, I only have materials, or well, the name comes from here, right? So if I call this one LookDev, then this is it's gonna be called LookDev. You can call it whatever you want, but basically this is what you want: geometry and materials. And then is where you do your asset creation. And this is a simplification of an asset creation. I mean, you could totally do it like this, but we're going to explore more complex ways of creating assets. We're going to be spending the next video probably another 2 or 3 hours only talking about asset creation in USD. It is a big topic because assets is, well, it's the main thing in any visual effects pipeline, right? But now we're using references. We're not using sublayers anymore. So we're using references. So what I'm doing in the first reference here, it is just bringing the model that came from here. Okay. But now we can define the structure up here where it says primitive path, because here it's only called geometry. So here I'm going to define my structure. So I'm going to call this prop head and then the name of the node. So this is going to give me something called prop head. So this is the Xform primitive called prop head. This is the name of the asset. And then we have the geometry inside, and then the different meshes that define this prim. Okay. Then I'm going to bring another reference node with my LookDev layer that we exported from here. And we do the same. We do prop head, which is the name of the asset, and the name of the node. So when we concatenate these two, when we put them together, this is what we get. We get a prop head that contains geometry and materials. So everything is very well organized here. Cool. But as you can see, my materials don't get assigned because here we only created the materials. So these materials, they don't know where they should be, right? It's like this antenna, we need to apply the material to the geometry of the antennas, same with the head and same with the helmet. So that's why you use an assign material node. Assign material, okay? I can do it from scratch. So with this assign material, we need to select a prim and a material. So we can take the antenna and assign the antenna material. There you go. Now it is assigned. If we want to keep assigning materials, we just create a new one and we take the head geometry and the head material. And then we do the same for the helmet geometry and the helmet material. And this should already be working. We don't see the materials because these are Arnold materials. So in order to do that, we need to go to Arnold. And most likely we're not going to see anything at all because we don't have any lights. So let's just create a light. There you go. And now we get our materials assigned here. Okay. If at any given time we change these materials, if we change the head to be like this other red, and we write the file again, if it doesn't update automatically, you might need to select the reference node and click on reload materials. There you go. And now you get your updates. If you're opening the scene, so if you know if a LookDev department is updating the materials and you as an asset creator, you're just opening a scene, everything will be automatically uploaded or after a while, but otherwise you can just click on reload. Studios usually have tools so everything can be reloaded just with a one click. All the materials, all the references get reloaded. But yeah, that's how it works. So now we've done that, and now we write a USD file called prop head asset version 1. Let's take a look. prop head asset version 1. Okay. So we haven't seen this before. So let's take a quick look here. So what are we doing here? We are defining a prim called model. And this this model has a reference to the model layer. Okay, it is a live reference. So anything that gets changed in this modeling department is going to be automatically updated in the asset. And then we have something called material binding. So we are getting the helmet geometry and we're binding a material, which is also a reference, that is prop head material helmet. And same for the other primitives. So we have an antenna geometry with a material binding referencing to this material. And same for the head geometry, material binding to this. And then here we're defining a material prim that is referencing to the look dev layer. Okay, so very easy to understand. We have defined model and material. We define that here, right? Prop head model, prop head material. And then those are calling the modeling layer, the look dev layer, and in between we do the material binding that comes from the assigned material. Okay, great. Then we go to shot assembly. What are we doing in shot assembly? Well, we are getting everything that we need for the shot. So let's pretend we need 3 different heads for this shot. So we have a reference that we can establish the structure here, right? So look at the scene graph tree. We have something called shot 01 that I'm defining here, something called characters, and then the name of the node. So I'm going to have something called shot 01 characters, character 01. Okay, and inside we have materials and models, because in this layer I'm calling the asset that we created in the asset department. But again, that's the good thing about references. You can rename them, you can change the structure, you can do whatever you want. And here, because we're establishing a shot, I want to contain my asset in a very specific location, which is shot 1 character 1. Then I'm duplicating this one, and that's the good thing about references, that you can duplicate them as many times as you want. So I'm going to duplicate it here, and the only thing that I'm doing here is renaming the node to character 2. So this one is also using shot 1 character, the name of the node. This is the structure, and it's pointing to the same file, to the same asset that we created here. And I'm doing that a 3rd time. So now when I look at my scene graph tree, what I have is shot 1 characters, and then I have 3 characters, and all of them are live references to the same asset. We write this as shot assembly version 1. Shot assembly version 1. And this is extremely simple. We are defining an XForm called shot1. We are defining an XForm called characters, and we're defining a character 1. But this character 1, it is just a reference of the asset that we created before. Same here, we are defining character 2, but it is a reference of the same asset, and we're defining character 3, and it's a reference of this asset. Extremely simple, extremely clean. So this is everything we need for the shot. So, shot assembly department done. We give this to the layout. And here is where we're starting to combine references and sublayers. So in the layout department, we don't really care about creating new things. We just care about manipulating new things. So instead of using references, let's use a sublayer. And this sublayer it is using the shot assembly USD layer that we created here. So once we bring this as a sublayer, we get exactly the same. Here we cannot change the structure. The structure has been already defined with the references node in the shot assembly department. So in layout, we just sublayer that and we get exactly the same structure for the shot. We do a layer break and now we start making changes in the layout. So I'm going to take this transformation and I'm going to move the character 1 over there and I'm going to move the character 3 over there. So this is what I get. So this is my layout. So, as a layout artist or set dressing artist, I do all these changes and I say, okay, this is looking great. So now I'm going to give this to animation department or FX department or whatever. I write this as prop head layout version 2. And if we take a look, the only thing we get here is over specifiers. We are just modifying something that existed before, which is the character 1. We are modifying the transformations, and character 3, we are modifying the transformations. As simple as that. Great. Then we go to animation, and here is all the sublayers. We don't use references anymore, right? Because we're not really creating anything. We're just we just need some layers. So what do we get first? Well, the shot assembly layer. Then we get the layout layer that we created here. So we get that. And now as animators, we need to animate these things. So we create a layer break. Then we do this animation and this animation, which looks like something stupid, I know, but you get the idea. So we're animating the shot. This transformation is using this character 1, right? So you just drag and drop here. And this one character 2. So just drag and drop over there. The USD layer is called prop head animation version 2. And you already know what you're going to get from here, right? So you would get over specifiers, but these are defined as time samples. And again, here you get transformations for each frame. So we have 72 frames. So this is the animation for character 1. And this is the animation for character 2. And that's the only thing we have here, over attributes. Fantastic. So then we go to shot 1. And in shot 1, we have a sublayer with the shot assembly. Oops. What did I do? Okay. With the shot assembly, another sublayer with the layout, and another sublayer with the animation. So at this point, we have everything that we created before. And remember that this is also using the references that we created in modeling and look dev and in asset creation. So all of this contains all the shaders and all the geometries and everything that we need. And again, any given time, anything that gets changed down the pipeline is going to be updated in our shot 1. We write this as shot 1 version 2. And same thing as before. We are only sublayering all this stuff. And if we bring that in a new reference or sublayer, it doesn't really matter at this point. So we can just this is using a reference. Well, the only difference in this case, once you have nested layers or a layer that contains multiple layers, is like if you do it with a reference, you can actually change the structure. So here, well, let me copy this first. So if I do it in a sublayer, this is what I get. Shot 1, characters and everything. If you do it in a reference, you could change this one to my movie. So I would have a different structure now, like my movie, shot 1, whatever, right? That's the power of references. But yeah, most likely you work with sublayers. So yeah, here I can start doing my lighting or whatever I need to do. Again, if I create a dome light and I look through Arnold, I should get everything working properly, as you can see here. And all of this will be animated, and I get everything that I need. And again, if I select this sublayer and I go to my layer stack, well, I need to select something in the SceneGraph tree first. I go to my layer stack, I see that here I'm using the shot assembly layer, the layout layer, and the animation layer. Okay. I don't see the first couple of layers like modeling and look dev and asset creation. That's because we are not really using them, right? So we are starting with the shot assembly layer. These are just references that get embedded into the shot creation. But they are still live, meaning that if I change anything in my in my shaders, for example, my lighting will be updated. Okay. Let's move that one over there. And let me go back to OpenGL. Right. But all of these you kind of knew already. Maybe not combining references with sublayers, but you knew sublayers and you knew references. So now it's time to talk about the new composition arc, which is payloads. And this one is new. So let's take a closer look. So payloads, let's go back to my slides here. You already talked about it, right? The main or the big difference between references and payloads is like payloads use deferred loading. So we always want to use payloads with geometry. So back in Houdini, we have our asset, we are defining the model, and then we're exporting this layer like that. Nothing new. This is all the same. Okay, this is all the same. We have this geometry structure coming from SOPs, and that's everything we need. Then we author, we create, we define our look dev. Exactly the same as before. So here we have our materials and our materials inside. Same as before. So the asset creation, this is where it changes compared with the previous method. So before we were using reference, then we were referencing the look dev, and then in here we were structuring the asset and finally assigning the materials. It is exactly the same here. We are also using a reference node, right? Same node, reference. We are also setting the structure here. So this is called prop head, and then it will be the name of the node. So in this case, it's model 1. Of course, it is model 1 because I'm using model somewhere else. I was using geometry before. So of course, if I call this one geometry, we would get like geometry 1, and maybe I renamed that one before. So model, okay, fine. So now we're defining this asset as prop head model. But here, this is just a reference node, and the reference type, it is set to reference files, and it's reading the USD layer. In here, we're reading the same layer, which comes from modeling, but we are changing the reference type from reference files to payload files. And as you can see, this is set to orange now. So references, they are green. Payloads, they are orange now. So my advice is, anytime you have something that is heavy or potentially can become heavy, like geometry, always use payloads. So every time I have some kind of geometry information or any big data, but when it comes to asset creation, that would be the geometry, always use payloads. So now here you can see this is just a payload. Okay. Then we have our lookdev coming from here, and the lookdev, it is just a regular reference. That's why it's green, and this one is orange. We could set this one to payload if you want, and now both of them are payload. They are both payloads, but it doesn't really make sense because they are shaders. Shaders are not expensive at all. I mean, they are expensive at render time, but they are not expensive memory-wise when you load them in the scene. So there is no point of using shaders as payloads. So this one is just a regular reference node looking at the lookdev that comes from here. Then we do our material assignments, same as before, right? And then we write the USD as prop head asset version 2. Let's take a look at prop head asset version 2. Okay, exactly the same as before. We are defining an XForm called prop head. Again, that is being defined here, prop head, for both the model and the materials. So everything is organized, prop head, materials, and model with everything inside. So we're defining that XForm. Then we're defining model 1, which is the name of the prim that we are using for encapsulating the modeling layer. And the reference is this one. But now, instead of saying reference here, it says payload, because this is a payload. If you check the materials layer, it's the same as the other one, but in here it says references, and here it says payload, because we are payloading the model, the geometry, but we're referencing default references, the materials. And then in between, we just have our material bindings referencing to the shaders for each of the geometries. Okay, as simple as that. Great. Then when we come to the shot assembly, we have same as before. We're using references, or we are referencing the asset that we created there. And as you can see, the payload is being carried over. It is orange, right? So now we don't have to do anything here. We don't need to define anything here because, oops. We don't need to do anything here because it has been defined here as a payload already. So here the only thing we need to do is just create a reference node, take this layer, right? So if I paste it here, it comes already as a payload. It is orange. So that's it. So we have our asset. Then we need, let's say we need 3 of these assets. So we use 1, 2, and 3. We name this one character 6, character 5, and character 4. And that's what we get here. Characters, because we're defining that here, right? Shot 1 characters. So we have shot 1 characters, and then is character 4, character 5, character 6. These are just the name of these nodes. And then all the geometry inside is a payload that comes as a live reference from the asset creation pipeline. Okay, we write this thing as a shot assembly version 2, and nothing would change there. It would be the same as before. What was the name again? Shot assembly version 2, shot assembly version 2. So yeah, we're not doing anything here. We're just defining the prims for the characters, and it's referencing these layers. Here, you don't see any information about payloads. I mean, this stage doesn't care if you're using payloads or not, because the payloads come directly from the layer. So this layer is the one that contains the payloads, which is the one we saw before, right? Where it says payload. But this one is just calling those layers. So it doesn't need to specify that this is a payload or whatever. All right, then we come to layout, and this is the same as before. So now we're starting to use sub layers. So we layer the shot assembly USD file that came from the shot assembly. We do a layer break, and then we start doing layout or set dressing. So we move that over there, we move that one over there, we write this as layout version 3. So layout version 3, same as we did before, nothing has changed. We are using over specifiers, and we are basically manipulating the transformation of some of those assets, in this case character 4 and character 6, right? So this one is character 4, this one is character 6. Then it comes to animation, and in animation, same thing. We have a sublayer for the shot assembly, then we have another sublayer for the layout that we created here, layer break, and then we start doing animation. So we have our little animation here, and then the USD layer, prop head animation version 3. It is only specifying some overrides that define some time samples, and same as usual, we have our 72 frames with a value per frame for, in this case, character 4, and here character 6. So that's it. Extremely simple. And now, when we are kind of working on the shot, lighting or whatever, we do the same, right? Sublayer, the shot assembly, sublayer, the layout, sublayer, the animation, and we can write this as a shot 01 version 3, and that is a nested layer. It was shot 3. Okay, so here we have our sublayers or nested layers. So we can bring this in a sublayer to start our lighting. So let's say we do, come on, go outside. Okay, so let's say here we start doing our lighting. So here we have the layer, and as usual, this is a nested layer, right? So if we select the shot 2 and we go to layer stack, here we can see all the layers being sublayer here, which are all the ones that we created before. But now with payloads, we can use this configure stage. So let's say that we have a scene that is extremely complex. This is, instead of 3 heads, this is maybe like a huge city. And then we're working on the lighting of one of the blocks of the city or one of the buildings of the city. We don't care about the rest, and it will be very expensive to have that in the viewport all the time or in the render. We can just use a configure stage. Configure stage. We can pipe it here. And remember, we used this one before with sublayers to mute layers, right? Now we have this section here that says load primitives, don't change. So this is going to use whatever has been defined in the previous USD layers, which in our case is everything. But now we can say something like load all primitives. So it's going to load everything that is inside. So if something was hidden or disabled, it will load everything. In our case, it doesn't do anything because everything is already displayed. But we can say set primitives to load. So now it doesn't load anything at all. Right? So if we have a huge scene, but for our shot, we only care about one portion of the scene, we can load only that portion. So here it says load paths from input. So we can just click here and, well, select the path there. That is one way of doing it. And we can say, I don't know, let's select this guy, for example. So we can do something like that, enable that one, and now it's only displaying the character 4, right? We should be able to do the opposite. We can maybe take that one and click there, and it should remove it if we do set primitives to load. Maybe I need a rule. No, that didn't work. I thought that would work. Okay, no, that doesn't seem to work. Okay, well, I thought this one would work, but it doesn't seem to. Maybe if I do it like that. No. Can I do it? No, it doesn't work. Okay, this one doesn't seem to work. That's weird. Okay, well, anyway, I always do it the other way around. So I always set primitives to load, so it doesn't load anything, and I just choose whatever I want to load. And oh, this is very important. Look at the orange bits, which again, these are the payloads. We know they are payloads because they are orange. As soon as we set this one to, look at the icon, right? It is loading everything. But as soon as we set this one to set primitives to load, these ones, they are unloaded. So it is loading all the references, so the materials are here, but the payloads, they are not here anymore. They are empty containers. So the structure is here with all the attributes and everything that is needed as a placeholder, but it doesn't really load the geometry. So as soon as we drag and drop one of these to be loaded, then it becomes a real thing. And now it's been loaded, both in the viewport and the render. We can just drag and drop the actual payload, or it is smart enough that if we drag and drop the character 4, it's going to know whatever is a payload and load it. Or if we load like the root, if we say SOT2, it loads all the payloads contained in SOT2, or just whatever we use. Okay, so this is very important because this doesn't work with regular references. So here, where we had regular references, so here they are all references, right? That's why everything is green. If we use a configure, oops, sorry about that. If we use a configure stage, connect that one there, and set this one to set primitives to load, it doesn't do anything because it doesn't understand you need payloads, and these are regular references. So this doesn't work with regular references. So again, my advice is like always use payloads with heavy stuff. Generally speaking, always use payloads with references. Okay, so those are payloads. Same as references, but a little bit, I would say, smarter or a little bit more flexible, and definitely use payloads all the time when working with big scenes. Okay, then we have variants. And variants are also extremely important, and you're going to be using variants all the time. More about variants later in the next episode when we're going to be talking about asset creation. So let me go to PowerPoint again, and these are variants. So variants are the same as references, but you can switch prims inside of the same asset. And this, of course, is very useful when you want to create variations of the same asset. For example, you might have a car, right? So this is your asset. This is a car. And you might want to have two different stages of that car. You might want to have a brand new car, and then you might want to have the same car, but maybe damaged. Or maybe you want another variation that is a blue car, because the original car was, I don't know, red. Or you might want to have a different variation of the same car that is dirty, right? Because depending on the shot, you might want to use that car in multiple sequences. And again, it is the same asset. All the time it is the same asset, but depending on the shot or depending on the sequence, you might want to use a different variation of the same assets. That's what you use variants. So again, it is the same as references, but they can contain multiple data inside. And you can set those variants using a node called add variant. And then in the shot, you can choose the variant that you want to use with another node called set variant. So let's take a look at that. So same as usual, we start in the modeling department. We create our asset. So this one is being defined as something called geometry and defining all the prims. In this case, they are all mesh prims. Then we do the look dev, same as before. We define something called materials. Again, you can define it here. And then inside you create all your shaders. In this case, Arnold materials for the head, the helmet, and the antennas. And then the asset creation is a little bit more complicated, as you can see here. It's not really complicated, but it's a little bit more elaborated, if you will. It's a little bit more complex, not complicated at all really. So the way it works, it is same as before. So you start referencing the model. And as you can see here, I'm payloading this reference. Why? Because it's a geometry. And I said before that as a general rule, always payload geometry. Then you can enable and disable in the shot when needed. With references, you cannot. Well, by the way, with references, what you can do is enable or disable in the viewport, of course. So I can just imagine that. Where do we have references? Here. So here, this is all references. So yeah, we can take a prim and we can say hide, right? And then you can just show it. So let's take the head, we can hide that one. Yes, we're hiding this from the viewport. If you render that, let's go to Arnold. This is also being hidden from the render, but it is still being loaded in memory. So it is not efficient, right? This is like hiding something in the outliner in Maya. Yeah, things are going to be a little bit faster and whatnot, but they are still being loaded in memory. So yeah, it's not the same thing. So let me show this again. Okay, get rid of this slide. Go back to variants. Right. So yeah, we are referencing as a payload the geometry. There is one difference here when using variants. Remember that before, when we are doing the asset, either using payloads or using references and sublayers, when we're creating the asset here, we're defining the structure, right? Because here it was only geometry. Here was only geometry. Here was only materials. And here is where we define the structure. So we have prop head geometry or model and prop head materials 1. So here we define the name of the asset, like prop head, then materials and models. When using variants, we don't do it. So as you can see here, I'm not defining the structure. I'm just calling this model 2. And again, it's model 2 because I have another model somewhere, right? So it's model 2. With the materials, same thing. We're referencing this, not defining a structure, just the name of the node, and then calling the lookdev layer as a normal reference. Okay, lookdev materials, we don't care about payloading them. So when you take a look at the structure, we don't have any structure. We only have materials and models, but we haven't defined the asset itself. And this is important because with variants, we do it down here. I'm going to show you in a minute. Okay, so now we have an assigned material. So we're assigning materials as before. We are just, right. So the materials, we created them here. And here we are assigning the materials. So if I take a look at my render, this is what I have. And this is my variation A. This is my first variation. Then if I want to create another variation, I just create another tree. And here, I'm actually assigning different materials. So it is the same materials, really, but I'm just doing different assignments. So my first variation or variation A was that one. Variation B, it is that one. So it's, different assignment of materials. And then I'm also doing a prune, which is basically deleting something. So I'm deleting the antenna. So if I connect that one there, now I'm deleting the antenna. By the way, and I wrote it here, prune turns off the visibility or deactivates a prim, but it doesn't delete it, okay? I think I said this before. In USD, you don't really delete data. You just enable it or disable it or turn it off or on, but you cannot actually delete information because you want the information in the layer all the time, because maybe another department needs to use that information. So you don't delete it, you just prune it. So prune is kind of like the blast node in Houdini. Let me get rid of this slide. So yeah, if you want to get rid of something, you use a prune, you connect the prune here, and now you can select whatever. This is a bug in the viewport, okay? Because I'm not actually deleting anything. So as soon as I update this, it should work. If it doesn't update, well, it is because this prune is doing something weird in the viewport, but it's not actually deleting anything. But here in the primitive pattern is where you select whatever you want to prune. So let's say I want to prune the helmet. I just drag and drop there, and you see like now it works. Now it updates everything properly. Okay, yeah, now it's working. So yeah, here I'm just pruning the antennas. And yeah, this is my variation A with antennas and shader assignments, and this is my variation B without antennas and different shader assignments. And then you create this add variant, and there are two of them: existing add variants to existing primitive, and add variants to a new primitive. We're going to explore this one. Add variation to existing primitive. This one is a little bit more complex, and as you can see, it creates like a loop here. We're going to explore this in the next video when we deal with asset creation. For now, let's stick to add variants to new primitive. So what you do in this one is you add the two variations, or you can have as many variations as you want, but in this case I only have two. You connect them here to the second input, both of them, and then here is where you define the structure, right? So the primitive path is set to the name of the node. So I'm going to call this one prop head 4. It is called 4 again because I have other prop heads somewhere. So now this one defines the actual asset. So as you can see, this one is called now prop head 4 materials to model 2. So if I call this one my asset, this is going to be called my asset and then materials and whatever. So I call this one prop head 7. Okay, because I have other prop heads somewhere. Okay, and then actually let's do it from scratch. Add variant to new primitive. So again, I connect my first variation here, my second variation there. I call this one my asset. And this structure has been defined. And now there is something called variant set. So this is whatever you want to choose for naming of your variations. So for example, imagine that I have what I said before, a car, right? So we can call this one car stage, for example, or car condition, or whatever you want to call it, right? So let's call it car stage. In my case here, I just called it variation, but you can call it whatever you want. And then here is using the name for each of the variation is going to pick up whatever you have here. So in my case, variation A or variation B, but you can give it a different name. So this variation A, I could say here something like car new, and variation B, I could call this one car dirty. If you don't want to use these names, fine. If for whatever reason you cannot rename these because let's say your pipeline says that you should always call the nulls something like output, then you can just give it a different name here. Otherwise, you can leave this blank and it will use whatever comes from here. So I could just call this one call, car new, or not, car new and car old or whatever, and it will be the same. I'm just going to call it variation A. Okay. Another important thing is, what is going to be the default variation, right? Because at some point you're going to use this asset in lighting or in layout or in look dev or in whatever. So if you have like 5 different variations, which one is going to be the default? Well, the default is going to be whatever is connected last. So in this case, the default is going to be variation V. Let's write this one as prop head variance version 1. Prop head variance version 1. There you go. And let's analyze this. So we're defining the next form called prop head 4. That is what we are defining here. Prop head, well, in this case it's 7, but it was 4 before when I wrote the file, okay? So we are defining prop head 4. And then we are starting variants. And the string or the name of those variants is variation. That's what I established here. I call this one variation. If this one was called type of car or car stage, we would get it here. Then the default is variation V. That's because the last one was variation V. And then we have variation A. It has defined a model that is payloading this USD layer. Okay. And then we're doing our material assignments here using this USD layer as a reference, which is the look dev. Same thing for variation V. We're defining a model that comes from a payload, referencing the modeling layer, doing these material assignments coming from this USD layer that contains the look dev. Very simple. But here you can see very easily that variation V is the default and the strength is variation. Great. So then we go to this shot assembly. So we're referencing regular reference, right? We don't need to do anything. We don't need to say that this is a payload or anything. It already knows. We are reading this variance USD layer that we created here in the asset creation. And here we can establish the structure of the shot. In this case, it's shot 1, characters, character 7. So we get shot 1, characters, character 7. Then I'm duplicating this asset and I'm going to call it character 8. And now we have 2 characters, 7 and 8. And then we have a set variant. So in the set variant, let me create it from scratch. Here's where you define which variation you want to use of the asset. So I can say, I know that I have 2 characters here, character 7 and character 8. At this point, they are all the same. This is not updating for whatever reason. That's just like a bug. That was a little bit unfortunate. Okay, that one and that one. Okay, anyway. So here we have our set variant. So we can say, oh no, actually it is working because the default variation is the one without antennas. Remember that, right? Because that one was connected, the last one. So we can say, okay, character 7, we want to use the default version. Fine, we don't have to do anything. But character 8, I want to use the other variation. So I can just drag and drop my character 8 here. The variation set, that is what we define here, which is variation. So variant set, we click here and we only have one defined, which is variation. And variation, it contains different variation names. So if we click here, we get variation A or variation B. So for character 8, we want to use variation A, which is the one with antennas. And then we write a USD file called shot assembly version 3. We take a look. And what do we have here? Well, we have defined shot 1, we have defined characters, and we have defined character 7. And this one is using as a reference this asset. Then we have character 8. It is also using as a reference the same layer as that one, but then this one is set to be used variation A. That's it. Great. Then we go to layout, and here we are sublayering the shot assembly that we exported here. We do our layer break, and then I'm going to do a transformation of character 8. So when I do that, I can see my two characters, right? So this is my layout. As simple as that. And from here, I can just continue as before. I just didn't create all the different stages, but I could do my animation, my shot lighting, my whatever I need to do here, my FX layers, whatever. Okay, but that's how you use variants. So yeah, variants are extremely useful. You're going to be using them all the time. And then we have the last two. So I'm going to go fast with these ones because we don't use these ones that much, at least in my experience. In more complex pipelines, you might use them. I think I see these being used mostly in feature animation because they reuse a lot of assets. In visual effects, we don't reuse them that much. But if you have a really heavy full CG show, you might want to use this as well. So inherits, and yeah, I'm warning you, this is a little bit hard to explain and maybe a little bit hard to understand, but inherits, they allow a prim to inherit properties from an attribute called class that needs to be defined first. The main purpose of inherits is this one. They are really useful for updating prims in a different layer without having to go back to the layer where the prim was created. That is, imagine that in the asset creation stage, I'm defining a geometry, and then I'm defining the look depth, okay? And then I'm taking this as a USD layer, and I'm taking this to layout, and then to animation, and then to FX, and then to lighting, for example. Okay. If I want to update the shaders of this asset when I'm in FX, what do I need to do? Well, I need to call the modeler or the look dev artist or the asset creation department. I need to call them and say, hey, can you please update these shaders and publish a new USD file? They will do that, and then everything will be updated in FX. Well, with inherits, you can create a class attribute here when defining the asset. So when I'm in FX, if I need to change anything from the asset, I can do it myself in the FX layer. I don't need to call the asset creation department and ask them to do it for me. That is the main purpose of inherits. I'm not a big fan because I like the assets to be fully locked, meaning that in my mind at least, and especially in big visual effects houses, only the asset department should be manipulating assets. I don't want animators or lighters or FX TDs to play with assets. In my mind, that doesn't work, but you can do it with inherits. Be careful because inherits are expensive because they need to carry on a lot of properties through the pipeline, through the different stages. So they are not cheap. And consequently, they are mostly used for materials. They could potentially be used for anything, but again, it's quite expensive. So use it only for materials because materials information is cheaper, as we saw before. That's why we don't need to payload materials information. Prims with this class specifier won't be rendered. Okay, so unless you specified, I'm going to show you that including in a minute, they won't be rendered. And also inherits are weaker than direct opinions in a layer. I'm going to show you what that means in a second. Okay, so modeling department, same as before, we create the geometry. Asset creation, this is where things change. So we need to create the class attribute. So you start with a node called primitive, right? So you create a primitive, And in this primitive node, you need to create a class attribute. So it needs to start like this, always. /_ and then you define the name of your asset. So this is /_ this is always going to be like that, and then prop head. And then in the primitive specifier, by default is define, and these are the specifiers that we know already, define and over. You need to set this one to class. When you do that, this is what you get, these two disks on top of each other. So this is just an attribute class that we have defined here. Then we reference the model as a payload, as usual. This is the USD layer that comes from here. And then this is very important as well. Here you can restructure your asset in the way that you want, but this first part needs to match whatever you wrote here. So it is class prop head, and then I'm storing the geometry in this geometry context. So when we take a look here, this is what we get. We get the class attribute and then the geometry. So same as before, same as here, but now we get the extra class attribute. Okay, the extra class attribute. We write this USD as prop head asset version 3, prop head asset version 3. And that's how it looks. I mean, you don't really see anything in there, okay? You're only defining the thing, defining the geometry coming from this layer, but you can see we have a class specifier called like that. That's the important bit. You need to specify this prim. Okay, then you are in a different stage. Let's say this one is a set creation stage. You start with the same thing. This primitive that matches the one that was created here. Same class, same specifier, sorry, which should be class. And then we start referencing the asset. So we get, oh, by the way, you see like here is not being rendered. So class primitives, they won't be rendered. They don't get rendered. If I disconnect this class primitive from here, then it is rendered. Okay. So this is a good way of checking that everything works. When you connect it here, if this matches this, it shouldn't be rendered. As long as it doesn't match, it won't work. Okay, so yeah, set creation, we just do the same thing here. Then we take our reference from the layer that we created before, and it is important to set this one to the same class attribute and set this one to the same class attribute. And here we need to set the reference primitive to reference specific primitive. So this is the primitive that we are calling, okay? The class prop head, the one that we are establishing there. Then we can, and as you can see, it doesn't get rendered, okay? Then we just say, okay, we need like 3 heads for our shot. So here we have this one, and here we don't need to specify the class specifier anymore. Here we just create our own structure. So I'm going to call this one set head 1, and I'm referencing this class attribute. Important. Now the reference type is not reference anymore. It's not payload anymore. It is inherit from first input. So it is inheriting from here. So this is just a regular reference. Here it is inheriting from there. So now it gets displayed, it gets rendered. So we have 1 head, 2 heads, 3 heads. Then we can move those. So we move them as we want. So now we have the 3 heads that we need. And when we take a look at the structure here, you can see that we have our original asset with a class specifier, and you can see everything inside. And then the set that we are creating with these three reference nodes and establishing here, set head 3, 2, and 1. So that's what we get, 1, 2, and 3. Then we can do some lookdep or whatever. So we're editing properties here. So we get something like that. And then we create the USD file that is asset set version 1. Let's take a look. Asset set version 1. There you go. Okay. So let's take a look at this. We have this class specifier, class prop head, that is referencing the head asset. Then we are defining set and we're defining head. And this is an inherit of this class attribute that was defined up here. Then we have some transformations. That's it for the head. Then we have the geometry. Then we have the head geometry with these transformations and these display color, these shading attributes that we created. And then same for head 2, we are inheriting this class attribute. Then we are overriding the geometry and the head, and then we are transforming it, and we are using a different color. Same for head 3, we are inheriting the class attribute, and then same thing. We are transforming it, and then here we are adding some colors and whatnot. Okay. So I hope it's clear. I know it's a little bit hard to understand first, but first we need to do the class attribute. Okay. This is referencing a specific primitive that again is the class prop head that was defined there. And then when we want to use this stuff, we just need to inherit from the first input, from whatever we created before. Okay, so that one, and that one, all of them are inheriting this class prop head, but here we can define the structure for our set or shot or whatever. Okay, then when we are in shot assembly, we can just take the layer that we had before. And if we write this as a USD, and by the way, this is just a regular reference. Here we don't have to inherit anything at all. That one was done here. So if we write this layer, it will be a nested layer, shot assembly version 4, shot assembly version 4. There you go. And this one is just calling that layer. That's it, as simple as that. Okay. And oh yeah, I wrote this here because this is important. Class is not here anymore. So when we were here defining, the first thing we did is defining the class at the very beginning. So what we see here now is the class that we define and then the actual set that we created. But when we write this layer and we load it here as a regular reference, we only get the set. The class is not there anymore, right? I mean, it is, you just don't see it here. Okay. Look at the difference. Here we see the class because we define the class here. Here we're not defining anymore. Here it's been inherited. Okay. So then when we are in layout or any other department, we bring this layer. Okay. So we have our set with the 3 heads. And as you can see, the geometry is always a payload. Then we do our layer break. And then this is where inherits become very useful. What if you want to change the asset? Again, before you had to call the asset department and ask them to do changes for you. Now you can do it yourself. So I can just create like an edit properties and select, as you can see here, I'm just selecting head 3 geometry, head 3 geometry head. So I'm just selecting this one there and changing the color. Now I have that power. I can do that. Okay. Then, because we had this class prop head, I can just create a primitive take this class prop head, that is the one that was defined all the time. And I call this one class. Here, I'm doing the same, but now I'm targeting something more specific, like the head. And I'm setting this one to over. So now I can just come here and change all the heads. Let me change the color of this one actually. Okay, that one is blue. I just changed this one to be blue. And that was a local change, right? So actually, let me disable that. So this is what comes from LookDev. So now I can just change the asset. And the asset, because we're using the same asset all the time, if I change the original asset, everything should change, right? So I just change, ignore this one. So here, again, I'm just creating this class thing, and I'm pointing to geometry head and setting this one to over. Right now, I want to override this class. I'm not setting this one to class anymore. I'm setting to override because the class was created before. So yeah, when I change the head, or I could change potentially, the entire asset if I wanted to, but let me just do the head. When I change the head, it's going to change for all the assets because it is the same asset, okay? The reason that I did this edit property before is to show you what I just wrote here, that inherits are weaker than direct opinions in a layer. So yeah, I am changing my asset with inherits, but if I have a direct opinion, if I'm doing something in this layer that I'm working on in the layout layer, this one is actually stronger. So it doesn't matter that down here, I change the actual asset because I'm changing something here in the layer. So inherits are weaker. All right. So yeah, I know it's a little bit confusing, but yeah, basically this is how it works. Once you have this class attribute, you can call it at any time, point to specific geometry, set the specifier to override, and then you can change the asset without having to go back all the way, doing it in the model or the asset creation stage and populating that. You can do it yourself. Again, you might not be using this all the time, or well, I know you're not going to be using this all the time, but you might want to use it. I mean, it is powerful, really. Okay. And the final is the specializes. So what are specializes? They are very similar to inherit, but less powerful. And they allow you to refine a prim. What is this? Well, imagine, and the way that I don't think this means exactly what I'm going to say, but this is the way that works in my head. Specializes are useful to create special assets. Okay, special assets. What is that? Imagine that I have a forest and I have like 20 trees and all the trees should be green, but I have a magical tree that I want it to be red. So I use specializes for that. I can say, okay, whatever changes are made to the asset, my special tree, I want it to be red all the time. So if you change the look depth, so all the trees are, instead of green, orange, I don't care. My special tree is always going to be red. That's why what specializes are for. Again, this is probably the one that I would use the least, but it exists. So let's take a look. Same thing. Modeling department, we define the geometry. Asset creation, we are referencing that model and we write it. Same as before, same as always. You can do your look there, whatever. So here, I'm referencing my asset. Same as we did before. Here, the difference is like before we did this, right? We created this class attribute. We don't need a class attribute anymore. The only thing that we need to do now is to bring the asset as a regular reference, set an structure here. So this one is called head. Point to the asset and specify a primitive. In this case, it's model 4. Model 4, that's because it comes from here, right? Model 4. So I take this one. If you don't know where to find that, you can just click here and it will show you, right? So by default is this one is set to reference automatically chosen primitive. So you need to reference a specific prim, and here you just select whatever you want to specify. If you want to specify something, only the antenna, you can only get the antenna. I want the whole thing, so I'm gonna select model 4. Okay, and then you use references, same as before, where you create your structure. So I'm gonna call this one set head 1, right? Set head 1. Here I need to point to the head, but now my reference type, instead of being reference, payload, or inherit, is going to be specialized from first input. So I do that with head 1, head 2, head 3. All of them are the same. Setting the structure, pointing to the primitive, and setting this one to specialize from first input. So now if you take a look at my structure, I have the same as before. Here is when I'm kind of specifying the asset, and then here's where I'm creating my structure. Set head 1, head 2, head 3. Same as here, okay? So remember that here we specify the class and then we create our set. Here is the same. We specify our hero asset and then we create our set. Then we can do any operations that we want. So I'm going to move some of these assets, and I'm going to edit the properties of one of them. Okay. So here is where I'm creating my special asset, right? So all of them are white, but this one is red. I want this one to be red all the time. So let's write this USD file as a prop head asset set version 2. Prop head asset version 2. Okay. And yeah, same as usual. I'm defining a head, looking at this reference, and then it is where I actually define my set, my head 1, but this one is a specialized. And then we add some transformations. Head 2 is also specialized and we add some transformations. Head 3, it is also specialized and we add some transformation. And then we have this head geometry that we're doing an override and we're changing the color, which is what we are doing here. So remember that here we only see 3 heads, and that's because class attributes won't get rendered. Remember that. That's why we only see 3. Here we actually made 3 copies, 1, 2, 3, but we're seeing 4. That's because the first one is still here, right? And this one gets rendered here when you are kind of creating the thing, because this is your source. But once you write this file and you load it, that one is not there anymore, because that one doesn't get defined. That one was used to define the set. So now when I take a look at this one, this is just a regular reference. The only thing that I see is my set with 3 heads. We're referencing here to set. Okay, so you need to click here and just point at set. Otherwise, it shows you the original head. So just click on set, which is what we define in the set creation stage. All right, that's it. So yeah, I wrote it here. The original asset is not there anymore, right? It is only what we created here. Okay, so yeah, this one is not there anymore, but here it's gone and it is there. But as you can see, you can point to that one if you want, the head, okay, the original asset. But oops, we don't want to do that. We want to point to the set. All right. So then in the layout department, we sublayer this guy that we created here. We do a layer break. And now I'm going to create a primitive. And this primitive is the asset, head geometry. Okay, so the asset is what is here, right? Head geometry or helmet or whatever you want to choose there. So I'm defining this primitive, head geometry, and this is head to over. I want to override this head geometry. So if I change the color, what's going to happen? Well, I'm going to change the color of my asset. When I do that, it changes, right? So now it's green or whatever color I want to use. But my special asset that I define here, and I said this one is a special asset, okay? All of them are special, really, but the only property that I changed, it was the head 3. So that one is my special asset. I want that one to be special, meaning that it doesn't matter if I update the asset, that one needs to be red. So when I'm here, even though I change my original asset, the special one is always going to be red. I can do another primitive. In this case, I'm pointing to the helmet with another override, and then I'm going to change the color. And now I change the color of all the assets, or all the, the original asset, but all the parts. Why is that? Well, because I never said that the helmet was special, right? I only said that the head was special, but not the helmet. So I can change the helmet, or I can change the antenna. And is it called antennas? Antenna geometry. No. Oh, sorry. My bad. I need to define it here, of course. So that would be antenna. And here it needs to be antenna. Okay, so now I'm changing also the antennas of the original asset, but yeah, this one was never specified to be a special asset, only the head. So that's what you use specializes for. Useful? In my mind, not that useful, but I'm pretty sure like some cases might happen when you want to use specializers. So again, specializers and inherits, both of them can be useful, but in my book, they are not the most used composition arcs. But the variants, payloads, references, and sublayers, they are the bread and butter of USD. Okay. All right. So I think I'm going to stop it here. I don't know how many hours have we spent today, but I'm pretty sure it's something close to 3 hours. We have covered quite a lot so far. I mean, we have covered, well, mostly USD composition and USD data and structure. So I think so far it's been 2 videos, right? And maybe we're closer to 6 hours of USD training. I know all of this is extremely boring and not exciting at all, but you need to know how USD works before you're able to do anything at all with USD. So next video, it would be all about asset creation. So I will show you, I don't know, I'm thinking from the top of my head, I'm not sure, but probably at least two ways of creating assets, like a simple way of creating assets, then a way of creating variations. And I will show you maybe 2 different ways of creating variations. And maybe I'm thinking of a 3rd version of creating assets. So 2 or 3. And I need to think about it, but probably I will show you how to create a tool. So every time you want to create assets, you can reuse that tool instead of doing everything from scratch. I will show you, though, how to create everything from scratch, but then we can wrap that into an HDA or another type of tool so you don't have to do it from scratch every time, okay? Because it would be pretty much the same all the time. All right, so yeah, I'm gonna stop it here. So if you have any questions, as usual, you can go to my Patreon, send me a message or post in the comments. I will try to reply as soon as I can, and I will upload all of these, so you have a good template here if you need to look at things. And yeah, hopefully in the next video we will make some pretty or some nice looking assets, reusing all these material from Animal Logic. And once you know how to create assets, it will get much better, because that's the most complicated stuff in USD, like how to create things from scratch. Then using them is quite simple. All right, so thanks again for being subscribed to my Patreon. I really appreciate it. And if you have questions, suggestions, or whatever comes to your mind, please let me know. Have a good one. Bye bye.